All right, good morning, Calc 2. We have our next problem number 3 here. We're going to use the integral test to determine if this thing converges or diverges. So using the integral test, let's go ahead and see about that. So I wrote down the problem here. A couple of things we have to check is this sequence, is it greater than 0? We can check the endpoint, kind of figure out like, well, where is it equal to 0? So if we get this 2, 1 point for that, then we'll know. We have to remember that x is going to be greater than, or n is going to be greater than or equal to 2. So we don't have to worry about anything smaller than that. So if I just set ln of n equal to 0 and solve, we get n equals 0. We get ln of n equals 0. So here we either get n equals 0 or we get n is equal to 1. So that would be where we cross over. So since both of these points are below 2, we only need to do like one little test point. Pick something easy, pick n is equal to e or something, even though that's not really going to be a thing we can do. But if we picked any test point in the region after 1, we're just looking for that. Okay, we'll pick 3 just for the sake of doing that. So we have 1 over 3 ln of 3. This is a positive number, so we're good with being positive. So 1, is it positive? Sure, check. Is it a decreasing function? So we'll go ahead and take our x, ln x, to the -1. We're just replacing the ends with x's for a moment, and we're just going to go ahead and say f of x equals, and then we're just going to take its derivative just to see if it's decreasing. So we end up with -1 x ln x raised to the -2. So that's the chain rule for that. Now we have to do the derivative of the inside. So the derivative of the first is 1 times the second plus the first times the derivative of the second, which is 1 over x. And then we'll go ahead and figure out what that's going to be. So we have ln x plus 1 over x ln x. This is all negative. Since after x is equal to 2, ln is going to be a positive number. So positive number plus a positive number, and then stick a negative sign in front of it. This is a decreasing function. This whole thing is always going to be less than 0. Is 1 over x ln x continuous on our region? This is after x is greater than or equal to 2, because that's where we're starting. Again, the discontinuities are going to be, well, the zeros are going to be where x equals 1, but we're going to have a discontinuity at 0. So we don't care about that because we are certainly after the fact. So we just have to go ahead and integrate this thing. So again, I'm going to replace the ends with my x's. So I'm just going to say integral from 2 to infinity of 1 over x ln x. And of course, this is an improper integral. So limit as say t goes to infinity from 2 to t, 1 over x ln x. We'll go ahead and say let u equals ln x. Du equals 1 over x. So we'll go ahead, dx rather. So go ahead and fetching out all of my substitutions. There's my du. So we have integral from 2 to infinity, limit, not 2 to infinity, 2 to t. Limit as t goes off to infinity of 1 over u, that's my natural log, du, that's my 1 over x dx. Go ahead and integrate that, and we end up with limit as t goes off to infinity of the natural log of the natural log of x here. Okay, these would technically be in absolute values, so we are good with that. And we're going to go from 2 to t. As I plug in my t goes off to infinity and evaluate this limit, the natural log of the natural log of t, limit as t goes off to infinity. This thing will hold, this whole piece will diverge because this will go off to infinity. So this diverges minus natural log of 2, but who cares because we already know it diverges. Okay, so when you're dealing with integral test, you check your conditions and then let it rip with the integral and you're all set. Okay, so thank you very much for watching. Good luck with the test, everybody, and hope everybody does well. See you in the next video.